So in section 4.5, we'll look at different applications and how to use systems of linear equations to solve problems. And you can use a substitution method or addition method, or you could graph them, although I think I've pointed out that graphing seems to be the least reliable means of solving a system of equations, unless you're using a graphing calculator. And then it's very reliable. But all right, we're going to use translations to create a system of equations. Okay, so find two numbers. So one of my numbers is going to be x and one of my numbers is going to be y. Find two numbers whose sum is 50. That's the equation for their sum is 50. And whose difference is 22. Difference means subtraction. All right, so here's my system. I'll put my bracket on there. And this is set up beautifully for addition because I already have a plus y and a minus y. So if I were to say x plus y equals 50, and x minus y equals 22, and draw a line and add vertically, x plus x is 2x, my y's cancel, and 50 plus 22 is 72, and then divide both sides by 2, so I would get x is 36. So I'm only halfway done, but if x is 36, go back to either one of these equations. I'll just pick the second one. X minus y is 22. If x is 36, 36 minus y is 22. So I'll subtract 36 from both sides. I get negative y is going to equal negative 14. No, opposite sign, subtract 6 minus 2 is 4. Right, negative 14. And then change the sign. So my two numbers are 36 and 14. Or 14 and 36. It just asked for two numbers. There's no concept of the first number or the second number. So go ahead and try practice 2. All right, if we look at classroom example 2, again, we're going to need to do translations. So here we have a first number is equals. A first number is 7 greater than a second number. Okay, so x will be the first number, and y will be the second number. A first number is 7 greater than the second number. There's that sentence there as an equation. Twice the first number, that's 2x, is, there's my equals, 4 more than, that's addition, 3 times the second. So the first number is 7 more than the second, twice the first is 4 more than 3 times the second. Find the numbers. There's my system. And this is set up for substitution. If x equals 7 plus y, I can substitute 7 plus y anywhere. Instead of an x, I'll put in 7 plus y. Bring the equals, bring the 4, bring the plus, bring the 3y. Distribute the 2, I would get 14 plus 2y is going to equal 4 plus 3y. Let's subtract 2y from both sides, and I'll get 14 equals 4. 3y minus 2y is just positive 1y, and then subtract 4 from both sides. So y is going to equal 10. And I have this great equation right here that x is equal to 7 plus y. So x is going to equal 7 plus 10. So x is 17. So my first number is 17, and my second number is 10. So go ahead and try practice 3. And again, you can use, if you'd rather use the addition method rather than substitution, or you'd rather use substitution instead of addition, use whatever method you want to solve the system. Okay, looking at classroom example 3. Here we have the admission price at a local weekend fair is $5 for children, $7 for adults. The total money collected was $3,379. And 587 people attended. How many children and how many adults attended? So in this particular case, rather than using X and Y, I'm going to use the letters C and A. C is going to represent the number of children. A is going to represent the number of adults. I could have made one X and the other 587 minus X. That would work fine too. We actually learned that already, but I want to kind of introduce something with the system of equations here. All right, so how much money is brought in for the children? $5 for every child. And then how much is brought in for the adults? $7 for every adult. This is how much money that's collected, $5 for every child plus $7 for every adult. Those two added together are going to equal 3,379. That's the amount of money I collect. And the number of children plus the number of adults is going to equal 587. So you could subtract a C or subtract an A. You could use substitution. I'm actually going to use the addition method. This is my system. And you know what? I'm going to multiply this equation here by negative 5. Why? Because then I'll have a 5C and a negative 5C. So my first equation is 5C plus 7A is going to equal 3,379. Now distribute the negative 5. Negative 5C minus 5A is going to equal 587 times negative 5 is negative 2,935. And now I'm going to draw a line and add vertically, and my C's will cancel. 7A minus 5A is 2A. And 3,379 minus 2,935 is 444. So in order to get A, I'm going to divide by 2. And so the number of adults is 222. And I have this good equation right here. The number of children plus the number of adults is 587. I'm going to use this now to find the number of children. The number of children plus, if there are 222 adults, totals up to 587. Let's subtract 222 from both sides. So the number of children would be 365. So we would say 365 children, 222 adults. That would be your answer. And if you wanted to check your answer, you would say 5 times 365 plus 7 times 222, and check and make sure that that's 3,397. And it would check out. So you're going to try practice 4.